In today's lesson, we are going to be looking at the present value. So this is a continuation of compound interest. And when we're dealing with compound interest, sometimes we know how much we want to have saved, right? Usually if we're saving money, we usually have a goal in mind, right? Whether saving for a new vehicle, saving for university or college, or we're saving maybe for a house, right? We usually have a goal or an end amount in mind of what we would like to have. And so if that's the case, we need to figure out, okay, how much money do I need to put in now so that I have that amount at the end, or when I want it. So when we're trying to find the present value, we're going to be using a slightly different formula, and it's a variation of our compound interest formula. So all the variables are going to be the same. It's just going to be a different formula. So our formula is going to be P, or the present value, is equal to A divided by 1 plus I to the power of n. Right? So it's the same letters, the same variables from our compound interest formula that we looked at in our previous lesson. They still mean the same thing. A is the future value, P is the principal or present value, I is the interest rate as a decimal per compounding period, n is the total number of compounding periods. And again, similar to before, we do have to do a small calculation for I and n before we can actually use it in our equation. So what we're going to do though is just look quickly at a few examples, just getting used to using this formula. So in the first example, calculate the amount needed to be invested today in order to have $5,000 in 4 years if the investment is compounded monthly at 3%. Now, the key thing that tells us that we should be using a different formula is the question asks how much is needed to be invested today, right? Or how much do we need now, right? So we do have to make sure we're reading the question carefully so that we understand what it is we're looking for. So first, we need to figure out what variables we have. Do we have the future value? We do. We know we want to have $5,000 in 4 years. So our A is 5,000. Our P, the principal, we don't know. That's what we're trying to calculate. Our I value, we do have our rate. It is 3%. But again, for compound interest, we have to take that percent as a decimal, 0.03, and divide it by the number of compounding periods, which in this case, it says compounded monthly. So that means 12 times. So I have to take 0.03, divide it by 12 to figure out how much interest or what's the rate per month. And we get 0.0025. Our n value is the total number of compounding periods. So because it's 4 years times 12 times a year, we get 48. Now we can plug it into our formula. P is equal to A divided by 1 plus I to the power of n. So 5,000 divided by 1 plus 0.0025, all to the power of 48. Now you can do this in multiple steps, or depending on your calculator, how comfortable you are with it, you could do this all in one step. And we should get $4,435.27. So that means that if we want to have $5,000 in 4 years, we need to invest $4,435.27 now. Second part is asking how much interest would the investment earn? So this is kind of going back to when we looked at simple interest. We do know the future amount, and if we subtract the present amount, that difference is going to be how much interest we've earned, or we would earn. So if I want to have $5,000 at the end of all of this, and I start with $4,435.27, I subtract those two values, to figure out how much interest I would have to earn. In this case, $564.73 is how much interest we would earn on this investment so that we would have the $5,000 at the end of 4 years. Next, John has a loan for $4,000 that is due in 3 years. He wants to pay his debt early. The creditor is willing to discount his loan at an interest rate of 8% per annum, compounded semi-annually. How much would the creditor be willing to accept as a down payment today? So again, we're going to fill out our A, P, I, and N. Those are 4 variables, and we're dealing with compound interest. Regardless of which formula, those are still going to be the same 4 variables. We want to figure out what we have now in the question. So John has a loan of $4,000 that is due in 3 years. He wants to pay his debt early. The creditor is willing to discount his loan at an interest rate at 8%, compounded semi-annually. So we see the compounded in the question anyways, so compounded semi-annually. How much will they be willing to accept as a down payment today? So that keyword today tells us we are looking for the present value. That means that $4,000 represents our future amount. That's how much it'd be worth in 4 years or in 3 years. Our I, or our rate, we have the 8% per year, but we need to calculate per period. So 8% divided by 2, because it's semi-annually. Semi-annually means 2 times. 8% or 0.08 divided by 2, 0.04 or 4%. And for our N, it's 3 years times 2 times a year to get 6 total compounding periods over this loan. Find our present value, P, we're going to use our formula, A divided by 1 plus I to the power of N. Plug in our values, so 4,000 divided by 1 plus 0.04 to the power of 6. And again, depending on how comfortable you are, you could do this all at once or break it up, simplify the bottom first, and then divide your 2 answers. 4 to the power 6. $3,161.26. So that means the creditor would be willing to take the $3,000 right now rather than wait the 3 years to get $4,000. Last example, Maria wants to invest enough money today to have $10,000 for tuition in 4 years. If she can invest her money at 6% per annum, compounded monthly, how much does she need to invest today? So again, that invest today, that tells us we should be using present value. We do see compounded monthly, which means we should be using the compound interest formula. So I'm going to write out my 4 variables, A, P, I, and N. We're looking for the present value or the principal. We're looking for P. If we go back through our question, we do have $10,000 for tuition. So that's how much we want to have at the end of 4 years. So that's how long we're going to be investing. And it's 6%. So for I, 0.06 or 6% divided by 12, because monthly means 12 times in a year. So 6% or 0.06 divided by 12, we get 0.005. For our I value, for our N, it is 4 years, but times 12 times a year, we get 48 compounding periods. Now we can plug this into our formula. A over 1 plus I to the power of N. 10,000 divided by 1 plus 0.005 to the power of 48. Type this into our calculator, and then we get 10,000 divided by 1.005 to the power of 48. We get $7,870.98. So that means if I want to have $10,000 in 4 years at this percent or interest rate compounded monthly, I would need to put in $7,870.98 right now, so that all the interest gained over over the 4 years would leave me with $10,000. Right. So this lesson looked at just a variation of our compound interest formula to help us find the present value, or how much we would need to invest today to end up with a certain amount at the end of a time frame. Right. So just another more application of the compound interest formula, because we might be more concerned about what do we need to put in now to have a certain amount or to reach a goal.